Hey guys, it's Mr. P again. This is example 3, again from 6.1. So this one's involving skydiving. So it says, suppose that a skydiver leaps from a hovering helicopter and falls in a straight line. He reaches terminal velocity of 80 meters per second at t equals 0 and falls for 19 seconds, at which time he opens his parachute. The velocity decreases linearly to 6 meters per second over a 2-second period, and then remains constant until he reaches the ground at t equals 40 seconds. The motion is described by the velocity function. And just to jog your memory about what this is called, this is a piecewise function where you have several different pieces. So we know that his v of t is 80 from 0 to 19, that's what that is. And then we open his parachute for 2 seconds, and he has this linear velocity. And then once his parachute's open, he kind of glides down for the last 19 seconds. So from 21 to 40, he's got the 6. All right, so we need to determine the altitude from which the skydiver jumped. So we know that we could figure out the altitude by integrating the velocity function, because the altitude would be the same thing as the position. So what we're going to do is we're going to do the integral from 0 to 40 of the v of t function, the absolute value of the v of t function, because we want it to be positive, dt. But since this has got several different pieces, we're going to have to write a long kind of addition sentence in relation to it. So this would be the integral from 0 to 19 of 80 dt. That's our first section from 0 to 19, plus the integral from 19 to 21, second function here, or second piece of the function, 783 minus 37t, and then plus the last little bit, the integral from 21 to 40 of 6 dt. All right, so we're going to go ahead and do the fundamental theorem of calculus on each of these. Some of them are going to be easier than other ones, but let's go ahead and get started. So if it helps, you might want to think that this is t to the 0 for the 80. So we add 1 and divide by 1. So this guy is going to be 80t, and we're going to evaluate that from 0 to 19, plus, okay, here, again, think of this as t to the 0, and this is t to the 1. So I'll put him in parentheses. So we add 1, divide by 1, so that's 783t, and then minus, so we add 1, divide by now 2, so this would be minus 37 over 2t squared, and we're going to evaluate that from 19 to 21. And then we got one more here, 6 dt. So think of that as t to the 0. So add 1, divide by 1. So this is 6t from 21 to 40. Queenie wants to go outside. We gotta finish this up, Queenie. Gotta do our work. All right. So let's go ahead and do this really quick so Queenie can go outside. We got this first part here. This would be 80 times 19 minus 80 times 0, plus, this is a big piece here. You definitely would probably want to use a calculator for this one. This would be 783 times 21 minus 737 over 2 times 21 squared, minus 783 times 19 minus 37 over 2 times 19 squared. Close that parentheses. And then we've got one more last little piece that I'll write down here. This would be 6 times 40 minus 6 times 21. Mixing up my notation a little bit. I'm sorry if that's confusing. So anyway, you do this big long string of calculations, and you see that he ends up starting at 1,720 meters up. So there's our answer. All right, good luck. I'll send out a remind with the homework problems.